Tonight, we're going to talk about Saturn, the planet everyone recognizes, the one with the rings, the one that ends up on every astronomy poster and every classroom wall. And here's the thing nobody tells you. Behind that beauty is one of the most extreme, most violent environments in the entire solar system. Winds so violent, they've never once stopped in 4.5 billion years. Storms that swallow entire planets. Rings that are disappearing right now and will eventually be gone forever. By the end of tonight, you're going to understand why the most beautiful planet in the solar system is also the scariest one. Before we get started, if you love exploring the depths of space as much as we do, take a second to like the video or subscribe. It's a simple action, but it helps this channel reach more curious minds like yours. Now, let's begin. Saturn is the sixth planet from the Sun. It orbits at an average distance of roughly 886 million miles. That's nearly 10 times farther from the Sun than Earth is. The light you see reflected off Saturn right now left the Sun about 80 minutes ago. When you look at it in the night sky, you're seeing a world almost 1 billion miles away. And yet, for all that distance, it's one of the 5 planets visible to the naked eye. People have been watching it for thousands of years. Ancient Babylonian astronomers tracked its movements across the sky and built tables predicting where it would be years into the future. The Romans named it after Saturn, their god of agriculture and time. For most of human history, it was just a bright, slightly yellowish point of light wandering slowly against the fixed stars. Then, in 1610, Galileo Galilei pointed a telescope at it for the first time. What he saw confused him completely. He described Saturn as appearing to have 2 companion objects, one on either side. He thought he was looking at a triple planet. Then, a couple of years later, when he looked again, the companions had vanished. He was baffled. He wrote that Saturn had devoured its own children, a reference to the mythological figure because the strange objects had simply disappeared. What Galileo was actually seeing, though he didn't understand it, were Saturn's rings tilted edge-on to Earth. When the rings are aligned exactly edge-on from our vantage point, they almost disappear. The rings are so thin relative to their width that at the right angle they essentially vanish. The first person to correctly identify them as a flat ring system was Christian Huygens, a Dutch astronomer, in 1655. He also discovered Saturn's largest moon, Titan, in the same year. And in 1675, Giovanni Cassini discovered a gap in the ring system, the dark division that now bears his name, the Cassini division, and proposed that the rings weren't solid, but made up of many separate particles. He was right. But even then, even as astronomers began to understand what they were actually looking at, the sense of beauty dominated. The rings were a marvel. The planet was a jewel. Nobody was thinking about the terror hiding underneath. To start understanding what makes Saturn genuinely frightening, you have to understand what Saturn actually is. Saturn is a gas giant. It has no solid surface, no ground to stand on, no crust, no ocean floor, no rocky landing zone. If you were somehow transported to Saturn and released into its atmosphere, you wouldn't land. You would simply fall, and keep falling, deeper and deeper into an atmosphere that gets thicker and hotter and more crushing with every passing second, until the pressure and heat became so extreme that the concept of falling would stop meaning anything at all. Saturn's diameter is roughly 74,000 miles. It is the second largest planet in the solar system, after Jupiter. You could fit about 760 Earths inside it by volume. 760. And yet, despite its enormous size, Saturn is the least dense planet in the solar system. In fact, it is the least dense object of any significant size in our entire solar system. Its average density is about 0.69 grams per cubic centimeter. Water has a density of 1 gram per cubic centimeter. This means that if you could find a bathtub large enough to hold a planet roughly 74,000 miles wide, Saturn would float in it. It would bob on the surface. That single fact is one of the strangest in all of planetary science. A planet almost 8 times the diameter of Earth, with a mass about 95 times greater than Earth's, would float on water. The reason for this is composition. Saturn is made overwhelmingly of hydrogen and helium, the two lightest elements in the universe. Hydrogen alone makes up about 96% of its mass. There is very little of anything else. No iron, no silicon, no dense rocky material in any quantity. It is, in essence, an enormous ball of the same stuff that makes up stars, just not quite massive enough to ignite fusion and become one. If Saturn were about 80 times more massive than it actually is, the pressure and temperature in its core would reach thresholds high enough to trigger hydrogen fusion. It would become a star. Instead, it sits in this strange in-between zone. Not quite a star, but not a rocky, solid world either. Something altogether different. And what happens inside that enormous ball of lightweight gas is where things start to get genuinely strange. The atmosphere of Saturn is where the first layer of terror lives. From space, Saturn looks smooth. Gentle bands of gold and cream, and pale brown wrapping around it in wide stripes. It looks calm. It is not calm. Those bands are the visible tops of enormous atmospheric systems, jet streams and circulation patterns, driven by Saturn's internal heat and its rapid rotation. Saturn rotates once every 10 hours and 33 minutes. For a planet nearly 10 times the diameter of Earth, that is extraordinarily fast. Earth takes 24 hours to complete one rotation. Saturn does it in less than half that time. That rapid spin distorts the planet's shape. Saturn isn't a perfect sphere. It bulges noticeably at its equator and is flattened at its poles. The equatorial diameter is about 74,000 miles, but the polar diameter is only about 67,000 miles. The difference, around 7,000 miles, is visible even in amateur telescope images. Saturn is the most oblate, the most visibly squashed of all the planets in the solar system. But the spin doesn't just distort the shape. It drives the winds. And Saturn's winds are extraordinary. Near the equator, wind speeds have been measured at around 1,100 miles per hour. 1,100 miles per hour. Earth's most powerful hurricanes produce sustained winds of around 200 miles per hour. The most devastating tornadoes on record have been clocked at around 300 miles per hour. Saturn's equatorial jet stream is moving at more than 3 times the speed of those record-breaking tornadoes. And it doesn't stop. It doesn't weaken when it runs out of warm ocean water to feed it. It doesn't dissipate when it makes landfall. There is no landfall. The jet stream simply circles the planet endlessly at over 1,000 miles per hour, powered by Saturn's own internal heat, radiating outward from the deep interior. It has been doing this, without pause, for as long as Saturn has existed. 4.5 billion years of unbroken, relentless wind. To appreciate what that actually means, what a wind of 1,100 miles per hour actually does, Consider that the speed of sound in Earth's atmosphere at sea level is about 767 miles per hour. Saturn's equatorial jet stream is supersonic by Earth standards. A wind that would be moving faster than the crack of a rifle shot, faster than a military fighter jet at maximum thrust. And it wraps all the way around a planet with a circumference of 227,000 miles. Nothing slows it down. Nothing interrupts it. There is no coastline where it makes landfall and loses energy. There are no mountain ranges to deflect or break up the flow. It simply circulates, powered from below by the heat rising out of Saturn's interior, and it has been doing exactly that since the planet formed. Now consider what it would mean to fly an aircraft through this environment. A modern passenger jet has a cruising speed of around 550 miles per hour. If you put that aircraft into Saturn's equatorial jet stream, the wind alone would be moving at twice the aircraft's cruising speed. The aerodynamic forces on any structure entering that atmosphere at those speeds would be ferocious. There would be no stable flight. There would be no level cruising. There would only be the howling wall of wind and the crushing pressure building from below. Saturn's atmosphere is not a place, anything designed for flight. As we understand, flight could survive. It is a place where the wind is the primary physical fact, and everything else, chemistry, temperature, pressure, is secondary to the sheer kinetic violence of the atmospheric motion. But the winds are only the beginning, because within Saturn's atmosphere, storms form. And Saturn's storms are nothing like anything that happens on Earth. Every 20 to 30 years, something extraordinary happens on Saturn. A storm erupts at equatorial latitudes that grows so large, so quickly, and so dramatically that it becomes visible from Earth through a backyard telescope. These events are called great white spots. The historical record of their occurrences goes back to the 1900s, and astronomers believe they have been recurring on Saturn for far longer than that. They are predictable enough that when one doesn't appear roughly on schedule, astronomers take notice. The most recent and most studied one occurred in 2010 and 2011. In December of 2010, a bright white spot appeared in Saturn's northern hemisphere. Astronomers spotted it almost immediately and began watching. Within weeks, it had expanded into a band of storms that stretched completely around the planet. A storm system that girdled Saturn at its latitude like a belt, completely encircling a planet with a circumference of roughly 227,000 miles. The head of the storm, the most convectively active, churning part, was alone about 12,000 miles wide. A single storm, feature larger than Earth. NASA's Cassini spacecraft, which was in orbit around Saturn at the time, had a ringside view. What it recorded was extraordinary. The storm produced lightning bolts roughly 10,000 times more powerful than the most powerful lightning strikes on Earth. 10,000 times. The radio waves generated by that lightning could be detected from Earth. The storm churned Saturn's upper atmosphere so violently that it dragged material from deep layers upward, mixing the atmospheric chemistry in ways scientists were still working to fully understand years later. It persisted for roughly 200 days before eventually merging with its own turbulent wake and fading. 200 days of continuous, planet-girding storm. And then it was over. Until the next one, perhaps 20 or 30 years from now, when the cycle begins again. But the great white spots, as remarkable as they are, aren't the most permanent, or in some ways the most eerie feature in Saturn's atmosphere. For that, you need to look at the North Pole. When the Cassini spacecraft first sent back clear images of Saturn's North Pole, scientists expected to see something broadly familiar. A polar vortex, perhaps. Some kind of circular circulation pattern near the axis. What they saw instead left them genuinely puzzled. There, sitting at the top of Saturn's axis, was a massive hexagonal cloud pattern. A hexagon. 6 perfectly straight sides. Each side roughly 8,700 miles long. The entire structure is large enough to contain 2 Earths placed side by side. It had been there since at least the Voyager flybys of the early